Hi everybody, my name is Tim Bradrick and I am demonstrating my game for the emerging technologies for mobile games from Full Sail University. If you see the home screen on my game, you notice that it's listing the geographic coordinates and the compass heading. I have a set of instructions in my game. If I exit out, you'll notice that it will update the information, and then I also have a list of credits, and we'll get another update, and you can see that they change and update. There are two different modes that I will be demonstrating for my game. Right now is the normal mode. There's limited use of it right now because I'm not going to be taking the device out into the neighborhood and walk around to demonstrate the geographic coordinates and the GPS. So I'll just demonstrate real quick the normal mode. Press the play game button, and you see that the screen rotates due to the compass, and up on the top it says go to the north area. So we are going to rotate the device until we see a light beacon. And there it is on the left side. And under normal play conditions, you would have the character walk in that direction, as well as the player walk in the real world in that direction. And you also notice when you tap the screen, you send a bolt of electricity, and then we can move forward, and then we can step back as well. And then the location that it's asking you to go to is randomly chosen from the 8 compass positions. We exit out, we go back into play game, and we'll see that a new location has been chosen. So go to the northeast section, and we see it over there, the light beam on that one. We're going to exit out and start demo mode and kind of demonstrate what the gameplay elements are. Okay. Now you notice that it's asking for the player to go to the demo area, and it's over in the other side on the left. Notice that the light beacon is a lot closer. We're going to move forward, and there is a set of tombstones, and when we get close enough, we will see the ghost, and we hear the music start. And then when we get close enough, we'll stop, and then we can zap the ghost, and we will get a congratulation message for having captured the ghost. We'll exit out and do that one more time to see a fail condition, and then we'll go forward. But this time we're just going to activate the music. Then I'm going to shoot 3 times and cause a lose condition. There we go. And then we're going to aim away from the ghost and then shoot 3 times. And you see that we've lost. Thanks. Hi, my name is Tim Bradrick, and this is a demonstration of the GPS function of my game. What I have done is, in the game, I have moved the avatar to a location where I have a ghost that will spawn if I walk a couple blocks to the north. If you notice up in the top, it's asking the player to move to the north, and the ghost will spawn above the tombstones if I go far enough. And that's assuming that the data connection is good. Going to take a look at the data connection. It is good. We'll keep trying. I have a timer in that data box down there, and it's keeping track of the time. And I'm just walking down my street trying to... There we go, there's the ghost. And then if I can, I'll move the character to aim at the ghost and shoot. And then I get a congratulatory message at the bottom. Hi everybody, this is my video regarding the code for my game, Ghost Tracker. My name is Tim Bradrick, and here are all the classes that I've written for the Unity game. The first one is the GUI for the home screen. It's pretty straightforward. It initializes some of the values and sets up the buttons for the screen. One of the things it also does is it accesses the GPS data. It goes through this setup sequence right here to make sure that you have a good connection. And then down here it accesses the information. And then what I do is I record the 4th decimal place and round off everything after that. And the player's movement throughout the real world is based off of that 4th decimal place, and whether they can change the values by walking around. And then I also give a north, south, east, west direction for each of them. And then down below are just some more of the buttons. 2 additional screens that I have that are pretty straightforward. The credits screen, I did use some sound effects and some textures and a ghost model, and I got those from the internet. They were all free to use, and I give credit on the credit screen. And then there are some instructions that I have, and there are the instructions. And then finally, the game screen itself is set up in this script. First off, it starts with setting the base values. It detects whether you're in demo mode or not. If you're in demo mode, it will not require the GPS signals for you. But it does go ahead and calculate it regardless of what the mode is, and that's what this section here does. And then based on the values that are here, there is another script that I have attached to inside of the world on the game screen that determines a random location. If you can imagine, the world is divided up in a 3x3 grid like a tic-tac-toe board. The player starts in the center and is asked to go to one of the other squares, and that's what this is setting up. 0 would in each direction would be in the center. And again, if it's not demo mode, the code goes and chooses 2 values between -1, 0, and +1. And if you have, for example, in the Y direction, if you have a +1, that is to go to the north. And then I just assigned a code number for each of the locations, just starting in the upper left corner with 1, and then the upper center 2, the upper right 3, and so forth. And it just determines the code name for that, and it is used over here in the spawn points 0, 1, 0, 2, and so on. And then that's all that this script right here does. Just randomly determines the location in that tic-tac-toe board. And then over here on the game screen, it displays the information and determines whether the player has gone in that direction or not. So for example, it's grabbing the latitude and longitude. It evaluates it based on the fourth decimal place, and then compares it from your starting location, which was on the home screen. And then if you increased or decreased in the proper amount, it will register that direction as being targeted equals true. So target north-south or target east-west equals true. And then, of course, if it's a demo mode or if it's not determined at all, it's automatically scored as gaining that target location. And then if, right here, if the player is in the correct location, the message changes that you're in the target area. And then down here, it chooses the message that is displayed in the game, which I showed in my other videos. And then there are some additional buttons, the walking forward, the touch events for the electricity, stepping back. It just takes a moment. It puts your speed as negative, and then it starts a coroutine so that it waits for you. If you look down here, the coroutine just runs for a second, and then you come back and it resets it to 0. And then here are the other buttons. And then in demo mode, I have some debugging information that's only displayed in demo mode. Okay. Next, I have 3 objects that are relocated at the beginning of the game. The 3 objects are the ghost, right there, the notice beacon, which is the big shaft of light, right there, and then a player detector, which is just a dome that when the player walks into it, basically the music starts and it starts counting the number of times you press the zap. And that's what this does. For those 3 objects, it relocates them. I found that I had to put them into a wait state just to make sure that the information was generated before the other locations were randomly chosen. So, and that's what this is. This is for the detector, this is for the ghost, and this is for the beacon, the shaft of light. I showed you earlier the ghost trigger. Here's the code for the ghost trigger. That is that dome. When the player walks into it, first off, it generates the flag that the player is not near the ghost, and then it hides the ghost again after a moment. It waits a second. And then when the player walks into the collider, it sets the ghost nearby as true, and then it plays the audio and then it loops through it, and that's the sound effect that you heard in the videos. And then each frame, it checks to see if both of the conditions are met. If the ghost is nearby, that means that the avatar has walked into the collision, and if the player has reached a target location, and then it activates the ghost and makes him visible again. When you tap the screen, there is a flag that is set that is just simply set to true, and over here that information is used. The play zap effect is set to true. Immediately it sets it to false. I found that when I was tapping the button, it would fire several shots all at one time. There is an audio that's associated with the shot, and then there's a mesh that is the zapping effect, and I attached it to the player controller, and there it is. It's just an effect that just randomly changes the beam right there, and that's what that does. Is it just lets it be visible, and then it waits a moment to turn it off. And again, another coroutine, the wait, zapping wait. It just waits 3/4 of a second, and then it turns it off, and then it decrements the number of zaps that you have initiated. And then it checks to see if you have exhausted your supply of charges, and if the ghost is not captured, and if not, then you have failed the game. And then if the ghost is captured, it waits to remove the ghost. One of the things that it does do that I just skipped over is this section right here. When you press the screen, it also tests for a zap hit, and that is down here. And let's see here, it's this section right here. It waits for a fixed update. That's so that Unity can readjust the colliders in its database. And then it takes the position and the facing of the player, and it casts a sphere in front of the player for a distance of 40 meters. These are virtual meters, of course. And then I applied a ghost mask, which is just a way to not detect the other objects in the scene. When I was testing it out, one of the things that it was doing was detecting the terrain, and it was detecting the tree and the tombstones and so forth. This right here prevents that. What I did is I took the ghost and put it into a layer, the ghost over here, and it is in a layer all by itself called the ghost layer. And that's what this does. It's a bit mask, and then down here I pass it, and so it ignores everything but what's in the bit mask. The physics sphere cast sends back information on the objects that were hit, and I just applied it, took its name, and then I'm comparing the name. There's a collider that I put around the ghost as well as the ghost itself. If you're inside of the collider, you might hit the ghost itself. And then if you hit the ghost with your zap, it's recorded as the ghost being captured, which triggers other things in other scripts. And then I originally had an animation on it, and I have the animation stop, and then finally, what I have here is the compass information. If you notice in the video, when you rotate, it changes the scene. And then finally, here it detects the compass settings. This is the information. What that does is it gives you the degrees from 0 to 359.99. And then what I do here is I take that information and I save it as the start heading, the current heading, and then I use a math F lerp angle to interpolate a change angle. So what it does is it takes the player and moves it along a time scale from the previous to the current, so it looks a lot smoother. And then here is where the player's position is changed right there. All right, thank you.